If cylinder is thermally insulated, at what speed V must the piston be moved upward in order that temperature of the gas remains constant? What do you mean by thermally insulated? I think it's trying to trouble you. Is it adiabatic process? Thermally insulated? But we are supplying, what do you mean by adiabatic process? No heat exchange, no? So from where the gas is getting heat? Through the current flowing through the resistor. So therefore it is not an adiabatic and temperature is constant. So therefore it must be isothermal. And since piston is moving with a constant speed, so therefore it must be isothermal. So what is isothermal? Which will convert where delta U will be 0. What all Q will be converted into work done. So the power supplied by the ether coil will be utilized to displace utilized to displace the piston. That's what happens here. Now it's asking at what speed V must the piston be moved upward in order that the temperature of the gas remains constant. So how to relate things? So let's come for isothermal process. What is the isothermal process? Option A, we are discussing isothermal process. Q equal to W, no? And dQ by dt should be equal to dW by dt. What is dQ by dt here? I square R. What is dW by dt? What are the forces that are acting there? Weight mg, pressure force, atmospheric pressure force, and the gas pressure force. Who will push the piston up? Definitely from as it is moving with a constant speed. So PS should be equal to P naught S plus mg. I'm equating forces here. Fine. So what is the rate at which work done by the gas? So what you should write dq by dt, power supplied. Let me write some sentences. Thermal power supplied by resistor to the gas. And what is this? Rate at which work done by the gas. So what is work done by the gas? Where do it will go? It is utilized to lift the piston and also to overcome the atmospheric pressure force. This should be. So how to calculate that? So shall we multiply this will be no, the next equation will be I square R should be equal to PS into V. Okay, this is the expression for the speed of the piston.
Sir,
Ah.
volume is changing, pressure is constant, temperature is constant, and number of moles constant, sir. How is it possible?
Isothermal process cannot happen.
Also, pressure is also constant only, sir.
Here actually, so what actually happens is continuously heat will be supplied by the heater. For it to get displaced, no, if PS equal to P naught plus slightly pressure what happen will increase. So it's like a sudden will not occur this one. So it'll be moving like this. So for it to undergo displacement, what is needed?
Pressure should not be constant, sir.
Pressure should be slight, like for it to undergo displacement, what is the needed here? No, pressure should be slightly increased. No,
Yes, sir.
Sir, piston is being moved by external agent.
no, not there. Where is the
At what speed U must the piston be moved? We cannot equate forces, sir.
No, here supply heat, the piston gets displaced, no, because of the work done by the gas, no?
No, sir. Someone else
Okay,
is
sir. No,
pulling
no,
it.
no, no, no. Okay, well, if cylinder is
External
turning,
force will also be changing.
no, wait. Let me read. I thought, okay, that one, at what speed V must the piston be moved upward in order that, okay, this one, I'll do one thing. I'll bring some external force. But what speed V must the piston be moved upward?
There we should remove P and we should write nRT by V and then we can do anything, sir. And it is not PS into V, it is PS in, sorry, that
Okay,
is
I'll
U,
do one
sir.
thing. No, I'll do one thing. It is moved is telling us sentence he has made. At what speed V must the piston be moved upward in order the temperature of the gas remains constant? What process it will undergo? Okay, this we'll do one thing. I'll bring from mathematically. Yeah. Okay, PV equal to nRT. So P dV plus V dP. Temperature constant, number of moles constant. So this will be 0. P dV is equal to minus V dP. dV is what? We can write PS dx by dt. V dP. dx by dt is what? V. Okay, this from here, this is the volume. Small letter I'm writing for this one. So this will become minus V dP by P into S. No. How to?
First two equations, what you wrote are correct only. Instead of PS, you should write PS plus F external. It's a constant value for the intermotion.
The energy equation, there's no problem. Only thing is
PS should be replaced by PS plus F external.
till here the gas only does work. Otherwise, who will shift that one?
Someone else is shifting.
External work done also we should consider. External force is also applied.
External agent you are bringing.
And that speed also will not be constant, sir.
First, we'll see practically. You should not violate our basic thermodynamics. Then we'll come to the question. Okay, the velocity, I'm getting expression for this. So this dP, there should be pressure difference is telling now.
He did not mention any pressure difference, sir.
No, for it to be valid, according to this thermodynamics.
It to be valid, we should
Not pressure.
external force should vary,
force
sir,
difference.
with time. External force should vary with distance and time.
If external force, it is moving with a constant speed means F external plus PS should be equal to P naught S plus mg.
We don't know if F external is constant, sir. That is one more unknown thing.
No need.
In this equation only, we'll change P to nRT by V, sir. I square R equal to PSU, P equal to nRT by V. We'll get speed as a function of displacement.
Here pressure is, you know. So there's a velocity, there's a speed. P equal to, I can write nRTV. Okay, any thing will get it. Now what is V? V is the
We can
volume.
write as SY, sir.
V I can write it volume as a function of Y. That much only, Beyond that, not possible. What is this PSV?
PSU, so that is actually velocity.
Velocity, that is velocity. I square R, there's a volume will be nRT, but okay, here we have anything temperature, contain 2 moles of ideal modern, number of moles we know, mass we know.
We know initial pressure and volume, sir. nRT equal to P naught V naught. We don't know initial volumes.
We don't know that. So some data is missing here. So this should be Y into S will come. So here SV. So this V will be now I square R Y by nRT. So we should know that initial temperature also. Okay, some data. Any data? Let me check below. Anything is there? Above, side. Nothing. Question incomplete maybe. Okay, let me just discuss the concept. What will be that? Okay, the expression for speed will be depends on that. This y is at any time t. I constant, capital R, there's a resistance, small r, I'll write it. Capital R, we are getting confusion. Okay, let's see. Is it temperature constant, I constant, smaller constant, number of moles constant, then as y increases, v will increase. No, not possible. Something. Constant speed is not possible.
Maybe that question has a printing error, sir. Instead of temperature of the gas remains constant, it should have been pressure of the gas remains constant.
If pressure of the gas remains constant, okay, then okay, I think this will be easy problem. Already we have done. No. Pressure constant means then P naught plus mg that will come. That will be much easier. I think this I'll be giving wrong. I'll do one thing. Shall I delete it? I'll be giving wrong information. We'll just